We can also solve proportions in tables. So remember when we started talking about equivalent ratios and how it's like a big multiplication table? That's how we need to view solving proportions and ratios in tables like this. All right, so here's my first example. We have 4 cats for every 5 dogs. So if I have 16 cats, I want to know how many dogs that we have in in our batch. So if we look at this, I can see that 4 is being multiplied by 4 to make 16. So that means my 5 also needs to be multiplied by 4, and that makes 20. So if I have 4 cats to every 5 dogs, that means for every 16 cats, I have 20 dogs. And again, I can go ahead and write it over here as well, off to the side. 16 to what number? And again, 4 times 4, so 5 times 4. Okay, moving on to our next row. If I have 5 dogs and it jumps to 25, then this is being multiplied by 5 because 5 times 5 is 25. So that means my 4 is also being multiplied by 5, and then that makes 20. So for every 4 cats, I have 5 dogs. So that means if I have 25 dogs, I have 20 cats. They're both being multiplied by the same number. Okay, let's look at our last row in our table. 5 is jumping to 60. I need to know how many 5s go into 60. There are 12 5s. So I'm going to go ahead and put times 12 because 5 times 12 is 60. That means that my 4 also needs to be multiplied. My black marker is fading out by 12, and that would make 48. So these are all equivalent ratios in here. 4 times 12 is 48. 5 times 12 is 60. All of these in the table are proportional to one another, and they're equivalent. Sometimes in tables, we need to work backwards first and then forwards. In the first example, I gave you the ratio in lowest terms and we worked off of there. In this case, my ratio that I know is in the middle of my table and I need to go up and down. So let's say for every 4 yards I walk, I run 30 yards. So I need to know if I walk 2 yards, how many yards am I going to run? Well, 4 and half is 2, so 30 and half is 15. So in this case, I'm going to be dividing by 2 when I'm going up. Okay, moving on and going down, I can start at this point right here, or I can go up here. So now I've got 2 separate ratios that I can go off of. It's up to me on which one I want to go from. So let's pretend I'm going to start still with this 4 and 30. 4 doubled is 8, so 30 doubled is 60. So in this case, I'm going to times by 2. So each of these is going to get times by 2. But what if I wanted to start up here? 2 goes into 8 4 times. So this would be 2 times 4 to make 8. So in this case, I would do 15 times 4, which would still give me 60. So I can go off of this ratio that I already started with, my beginning, or I can go off my top ratio in lowest terms. So it's up to me on which way I want to go. So let's look at this last one. I've got 150 yards that I'm running. So I don't know how many 60s make 150. I could figure out how many 30s make 150, but a lot of us would say, I really want to use this 15 because I know 15 times 10 makes 150. So I can multiply here and go times 10. So if 15 times 10 makes 150, then 2 times 10 makes 20. So I can go right there and start up at my lowest terms in my table. I could go, some of us would say, well, I know that 5 30s go into 150. So I would multiply 30 times 5 and get 150. So then I would take my 4 and times it by 5 and I would get 20 again. So when you're multiplying and using ratios and tables, you can start in different points depending on what the terms are and how good and fluent we are with our multiplication division facts. So there's another example on making ratios and tables. Let's do one more. Here's another case where I have burgers to hot dogs and I do not have my beginning ratio in lowest terms. I have 35 burgers to 15 hot dogs. And I need to fill in my table going up and down to figure out how many hot dogs and burgers I would need depending on the other factor. So if I have 35 burgers and 15 hot dogs, to go up, I'm going to divide, and to go down, I'm going to multiply, just like a multiplication table. So I'm going to go ahead and go down because I think that's where most sixth graders would start with. They would see the 15 as being doubled to 30, so we would take the 35 and double it to 70. So since the 15 is being doubled, then the 35 also needs to be doubled as well. Okay, now 15 going to 12. This is one where 15 does not go into 12 evenly, or 12 doesn't go into 15 evenly. So I'm going to need to jump up to my first line in order to do my second line, because 35 and 7 are compatible numbers in terms of, I know that 5 sevens go into 35. So again, I'm going up, so I'm going to be dividing. So 35 divided by 5 makes 7. So 15 divided by 5 makes 3. So going up again, I'm going to be dividing. Now, since I have that ratio and it's in lowest terms, I can find out my second row much easier now with my math facts. I know that 4 3s go into 12. So this is being multiplied by 4. So that means 4 sevens is 28. So for every 12 hot dogs, I'm going to need 28 burgers. So again, when we're using proportions and tables, we need to figure out where our beginning ratio is. So in this case, it was 35 and 15. And we move up and down accordingly and figuring out what's being multiplied or divided to figure out what my missing numbers are going to be.